Good morning students. Welcome to Sunain Sir's online classes. In this video, I am going to explain you image formation cases of convex lens. These 6 cases are very important regarding new pattern of SSC exams. Let us see all the cases in this video very clearly. First, let us see what is image. Image is nothing but image will form at a point where two refracted rays meets. Wherever two refracted rays meets, their image will form. So there are two types of images. First one is virtual image and real image. Virtual image is one which cannot be captured in screen. It forms inside the lens or mirror. Virtual image, as it forms inside the lens or mirror, it cannot be captured on the screen because it will be inside the lens. It will not come outside the lens. It will not come outside, it will be inside the lens only. So that is why we can see that image directly with our naked eye. It can be visible to naked eye directly without screen or without any white screen or without any screen. So it forms on the same side of the object. Virtual image always forms on the same side of the object. So best example for virtual image is image which you see in your face, which you see your face every day in the mirror. Every day before coming to school, you will comb your hair by seeing your face in the mirror. The image which you see in the mirror is nothing but virtual image. It will be inside the mirror only. It will not come outside of the mirror. That is why it is called as virtual image. It cannot be captured on screen. Now let us see what is real image. Real image is one which can be captured on screen. Real image is one which will be captured on screen. Without screen we cannot see real image as it forms in the air. Real image will form outside the lens and it will form in the air. That is why in order to see that image which is forming in the air, we need to place a screen at that point. Wherever the image forms in the air, at that point if we place white screen, only then we can see that real image. Otherwise we cannot see that image. That is why it is always captured on the screen only. We cannot see with our naked eye directly. It forms on the other side of the object. Real image always forms on the other side of the object. As real image forms in air, in order to see real image, we need white screen. Definitely we need white screen to see the real image. Best example is movie which we see in the theaters is a real image which is captured on the white screen. We will see movies in theater, that image is nothing but real image which is captured on the white screen with the help of a projector. Now let us see what is convex lens. Convex lens is a converging lens with spherical converging surfaces on both sides to converge the light rays falling on it. Convex lens is nothing but a lens which will have two converging surfaces on both sides in order to converge light rays at a point. It is also called as magnifying lens as it is used mostly for magnification purposes. As it is mostly used for magnification purposes, it is called as magnifying lens. Best example is magnifying lens used to read small letters. The lens which you see in the image, this is nothing but magnifying lens. Now what is image formation? Image formation, we know that image forms at a place where two refracted light rays meets. Wherever two refracted light rays meets, their image will form. For example, if this is a convex lens and in front of the convex lens there is an object placed. For example, say this, let us take it as a pencil. In front of a convex lens you have placed a pencil. So from the pencil there will be different light rays coming in different angles and different positions. Different light rays will be coming in different positions, but after passing through the lens, we don't know how all these light rays will travel. We don't know how this light ray will travel, how this light ray will travel, how this light ray will travel after passing through the lens. After passing through the lens, we know that they will undergo refraction and they will divert from their path. But how their diverted path is going to be, we don't know the path of all these light rays. We don't know the path of these refracted light rays, how they are going to move after passing through the lens. That is why we are not going to use all these light rays. So we are going to use only two light rays whose path is known. So that is why, if you take, let us take a convex lens. Let us take a convex lens, and in front of a convex lens, for example, if pencil is placed, from the pencil there will be different light rays coming in different positions, but we don't know the path of all these light rays. We know the path of only two light rays, that is, first one, a light ray which is traveling parallel to the principal axis, it will pass through the focus. It will pass through the focus. We know the path of this light ray, that is why this light ray we are going to use in image formation. And second light ray is the light ray which is passing through the optic center. The light ray which is passing through the optic center, it will go straight without any deviation. Without any deviation, this light ray will go straight without any refraction. Hence, if we use these two light rays, and wherever these two light rays meets, their image formation will take place. That is why, for that purpose, we are going to use these two light rays to know where the image is formed and how it is going to form. But not only these two light rays, there will be different light rays coming from the object in different directions, in different positions, but we are not going to use all these light rays as their path is unknown. Their path is unknown. We are not going to use these light rays. So when object is placed in front of lens, so many light rays coming from the object will fall on the lens, but we cannot trace the path of all these light rays after their refraction through lens. After undergoing refraction through lens, we cannot trace their path. That is why we will use only two light rays whose path of refraction is known. That is, first one is which is moving parallel to principal axis, it will pass through focus after undergoing refraction. And another one is the light ray which is passing through optic center, it will go straight without any deviation. These two light rays we are going to use to know the point of formation of image. Now let us see terminology of convex lens. First one is focus. Focus is a point where all the light rays parallel to principal axis meets. For example, if you take a convex lens, in this convex lens, if the light rays coming from the infinity, the light rays coming from infinite distance, that is, the light rays which are coming parallel to the principal axis fall on the convex lens, then all these light rays will meet at a point. That point is called as focus. Focus is a point where all the light rays which are coming from infinite distance, or the light rays which are parallel to principal axis. The light rays which are coming from infinite distance will be parallel to the principal axis. They will be parallel to the principal axis. When all the light rays which are parallel to principal axis falls on the convex lens, they will meet at one particular point. That particular point is called as focus. It is called as focus. Next, center of curvature. Center of curvature is nothing but center of spherical surface of lens. We know that lens will have a spherical surface. For example, if you take a lens, this is the spherical surface of lens. This is one of the spherical surface and this is second spherical surface. If you complete this spherical surface or if you complete this arc, it will form one circle. So whatever the center of this circle is there, that is called center of curvature. And similarly we have another spherical surface. This is another spherical surface, and if you complete this spherical surface, it will form one circle. That center of circle is called as center of the curvature. So for a convex lens, since there are two spherical surfaces, there will be two centers of curvature, and we know that this is center of the curvature and this is circle. This is one of the circle, and part of this circle will act as spherical surface of the lens. This is one of the circle, and distance from center to the spherical surface is nothing but radius. Radius is nothing but distance from center to the spherical surface. This is also radius and this is also radius. That radius of spherical surface is called as radius of curvature. Radius of curvature is nothing but radius of the spherical surface. This is spherical surface and this is center. Distance from center to the surface is nothing but radius of curvature. So radius of curvature is nothing but radius of spherical surface. Since lens has two spherical surfaces, it will have two centers of curvature and two focuses. Since it is having two spherical surfaces, it will have two centers of curvature and two focuses. Now let us see actual cases of image formation. So case 1, when object is placed at infinity. When object is placed at infinity, so what happens? Light rays which are coming from object at infinite distance will be parallel to the principal axis, and when all the parallel rays passing through the lens, they will meet at focus. We know that the rays which are parallel to principal axis, when they fall on the lens, they will meet at focus. Hence image will form at focus. So here you can see the image which is formed at the focus is a point image. It means it is highly diminished image. And here you can see image is formed on the other side of the object. We placed object this side of the lens, whereas image is formed this side. So since image is formed on the other side, it is called as real image. Real image is one which forms on the other side of the object. So here image formed is real, and here you can see it is a point image. It means it is highly diminished image and it is formed at focus. It is formed at focus. So image characteristics are, first one is real image and it is highly diminished image or point image and it is formed at focus. And case 2, object placed beyond center of curvature. So when object is placed beyond center of curvature, this is object, and we know that we are going to use two light rays. One light ray is which is parallel to principal axis. After passing on the lens, it will pass through, after falling on the lens, it will pass through focus. And second one is light ray which is moving through the optic center. It will go straight without any deviation. Hence these two light rays are meeting at this point. So at this point image formation takes place. This is the image. As you can see here, this side we placed object, this side we placed object, and image is formed this side. It means image formed is real. And as you see here, image object is placed straight. It means you have placed pencil straight in this way, whereas you can see the image inverted. Here image formed is like this. It means you can see pencil as upside down. Image will be inverted. And image size, you can see here, it is formed with decreased size. Hence image formed is diminished image. Here object is this is the size of object, whereas size of the image is somewhat decreased, hence image is diminished, and image is formed between f and 2f. It means image is formed between focus and center of curvature. So image characteristics are: image formed is real image formed is diminished image, and it is inverted image, and it is formed between focus and center of curvature, that is f and 2f. Center of curvature is represented by 2f. 2f means nothing but center of curvature. And one more important point is, in your textbook convex lens is represented by this symbol. This symbol gives representation of convex lens, whereas this symbol gives representation of concave lens. In your textbook this symbol is represented to show concave lens, and this symbol is represented to denote convex lens. And next, case 3, object placed at center of curvature. When object is placed at center of curvature, again we are going to use two light rays. One is light ray which is moving parallel to principal axis. After passing through lens, it will pass through focus. And another one is light ray which is moving through the optic center. It will go straight without any deviation, and these two light rays are meeting at exactly at 2f. So light rays are meeting exactly at 2f. And if you see image characteristics, image formed is inverted image, and this side we placed object, whereas this side image is formed, hence image is real image, and it is inverted image. It is of same size as that of object, so it is same size, and it is formed exactly at 2f. So if you see image characteristics, first one is, it is real image, it is inverted image, it is same size, and it is formed at center of curvature, that is it is formed at 2f. Next, case 4, object placed between focus and center of curvature. So when object is placed between focus and center of curvature, so here again we will use two light rays, that is light ray which is passing parallel to principal axis, it will pass through focus, and second light ray which is passing through optic center, it will move straight without any deviation. Hence these two light rays are meeting beyond 2f. These two light rays are meeting beyond 2f. And I request you to remember one point. So whatever it is happening, we are drawing that image, we are drawing that diagram. So whatever you draw, it will not happen, because if you want, you can make these two light rays meet here also. But whereas if these two light rays meet here at this point, it means image is forming at this point. But that is not correct, because whatever you draw, it will not happen. Whatever it is happening, we are drawing that. That is why I request you to draw the diagram exactly however it is there in this video. Okay, so these two light rays will meet, at this point beyond 2f. So image formed is real image here, it is inverted image, and as you see, its size increased. Here object size is this one, and here image size is this one. Its size increased, it means it is a magnified image, and it is formed beyond 2f. So if we go to image characteristics, so image is real image, it is inverted image, and it is magnified image, and it is formed beyond center of curvature. And I request you to follow the diagram as it is, without your own creation, without your own creativity. Follow the diagram as it is, because whatever you draw, it will not happen. Whatever it is happening, we are drawing, we are trying to learn that, we are trying to draw that, and we are trying to represent that in the exam. Next, case 5, object placed at focus. The light rays which are coming from the object, one is the light ray which is going parallel to the principal axis, it will pass through focus, in this way. Another light ray which is passing through the optic center, it will go straight without any deviation, and these two light rays are parallel to each other, they will not meet at all. Two parallel rays, you know that they will never meet. Two parallel rays will never meet. That is why we will say that image is not formed at all, or in other words we will say image is formed at infinity. It means indirectly image will not form at all. And here you can see image formed is real image. This side we placed object, another side image is trying to form, but anyways it is not formed, but because these light rays are moving on the other side, we will say image is real and image is formed at infinity. And since these two light rays are not meeting and they will meet at infinite distance, that is why we will say image formed is highly magnified image. Image is real image, highly magnified image, and it is forming at infinity. First of all, image is not formed at all, that is why there is no meaning at all in saying real image. But since the light rays are moving on the other side, we will say real image, and if at all image forms at infinity, it will be highly magnified image. That is why we will say it as highly magnified image. And case 5, object placed between focus and optic center. Object placed between focus and optic center. Whenever object is placed between focus and optic center, first one, the light ray which is moving parallel to principal axis, it will pass through focus. Another one is the light ray which is going through the optic center, it will move straight without any deviation. And here you can observe, if you observe, these two light rays are diverting from each other. It means this side there is no chance for these two light rays to meet, because they are diverting from each other. Whereas if you extend them backwards, there is chance for them to meet. Similarly here also these two light rays, they are diverting this side, there is no chance for them to meet. That is why if you extend them backwards, there is chance for these two light rays to meet at this point. That is why image is formed here. At this point image is formed. And if you see here, image is formed on the same side of the object. This side we placed object, and on the same side image is formed. That is why this is virtual image. And if you see here, object is placed straight and image formed also straight. That is why it is erect image, and it is a virtual image, and it is a magnified image. Its size is larger than the object. It is a magnified image, and it is formed between focus and optic it is formed between focus and center of curvature. So if you see here, please I request you to observe the diagram once again and to learn this diagram perfectly. Observe this diagram once again and learn the diagram perfectly. Now let us see image characteristics. Image formed is virtual image, image is erect, and image is magnified, and it is formed between focus and center of curvature. Thank you for watching the video.